Hello. For this practice, we're going to use different tools that they help us to measure different materials. To begin with, we're going to use this one that it's a micrometer. We're going to use also a compass. The compass works with the ruler. We also have the analogic vernier and the digital vernier. Okay. To use the micrometer, you gotta turn it down until the desired length. Then you're gonna scrub it and close it until you get your size. Here you can see the length. This is in inches, and there are like decimals for the inches. For example, this one is gonna be 0.3 because there's in the tree, and then you gotta find the line that it's matching with another one. So you have 0.3, 15, and 4 because it's matching. The number 15 is matching with the 4, so it's gonna be 0.3154.
Well, here we have a ruler. It's a piece of metal that have different distances. Here we have centimeters, and in this side we have inches. The ruler also works with a compass. This one you can scroll to the desired distance and measure whatever you want to measure. For example, here for the external diameter we have this distance, and then we compare this distance with the ruler. Here we have that is 2.5 centimeters. This is the way it works, the ruler and the compass.
Okay, here we have two verniers. This one is a digital one and this one is an analog one. So in simple words, this one is expensive and this one is cheap. Both of them work the same way. So I'm going to start with the digital one. You press this red button to turn it on or off. This button is to lock the zeros. For example, let's say, for example there, it is saying minus 0.01 millimeters. So I can put the 0 and it turns back to its original setting. Here I can change with this blue button between inches and millimeters, but because we are using the international system, we're going to use millimeters, and I can use this hole, let's say, on the bottom to measure external diameter. For example, the external diameter of this bearing is 35.12 millimeters, and I can use the part on the top, and we can use this part on the top to measure the inner diameter, which for this bearing is 10.02 millimeters. And finally, here you can see it has like an extension here that as it gets longer, the measurement increases. So that means we can use this part to measure depth. How we can use it? We just place it here and put it until it touches the bottom, so we can see the depth of this bearing is 11.02 millimeters. And we can use the analog vernier on the same way. But here we have to analyze all the lines and numbers it has. For example, using the same bearing, we can see the 0 is exactly at 35 millimeters. The bottom part of the analog vernier is millimeters and the top part is inches. So you can see as the 0 is perfectly aligned with the line, we don't have to get any further, so it is 35 millimeters. We use again the top part to measure inner diameters. We can see it is 10 millimeters, perfectly aligned. And again, this extension to measure depth. So we will do it with this bearing. And we can see here, the 0 is just next of 11 millimeters. So we're going to use the next numbers on the part that moves, and we're going to see which number is the first one that forms a vertical line with the fixed part of the vernier. We can see here The next number is 1, and that is the first decimal of the millimeter. So that means the depth of this piece, according to this vernier, is 11.1 millimeters, and that's how you use this vernier.
In conclusion, I learned how to measure the bearings in different ways and new ways. For example, this new instrument, I didn't know how to use it, and now I can say it's a very exact and very useful instrument. However, I didn't like it so much. I think it's not that precise for me because my view is a little bit difficult to see the different instruments and all these little numbers. But the most useful I think is the digital vernier for me and the ruler.
Well, and for practice number 2, for the measurements and metrology, we used a couple of instruments to measure certain diameters and distances in 2 ball bearings. And we used from verniers, both digital and analog, to a micrometer and a compass and a ruler. My favorite pretty much was a digital vernier because it's really easy to use, and you have a digital like distance marker, which is also pretty easy to read and to interpret. Yeah, I also like the micrometer, but the small numbers and lines here are quite hard to read, so you can easily make a mistake between decimals because of the system they use to measure them. And the ruler was pretty easy to use. It's just you put the ruler right there, but I don't think it's close to the precision of the micrometer and the verniers. So yeah.
Now that I have measured successfully these bearings, I can conclude that without a doubt the compass and the ruler were the worst method because of the decimal lines it has on the ruler and the bad precision we may have. On the other hand, this vernier analog I found to be the most useful because it's very exact. On the other hand, the digital vernier may be bad calibrated or configured the wrong way, something may happen, but this analog vernier will be the best tool and the one I prefer to use.
For example, for me, my conclusion is that in this case, because we have to measure this bearing, the best tool for measuring this is the vernier, because it has all the properties for measure this one. Because we measure the external diameter, the internal diameter, and also we can measure the depth of the bearing. And the one that don't work for me as well is the compass, because it's too unexact, because we can measure here one thing and then every time we repeat the procedure it's going to give us a different number and it's not too specific the measure.
Okay, so each instrument for measurement that we use in this practice has disadvantages and disadvantages according to the measurement you want to do specifically. Many people like the vernier because it's very versatile, but the micrometer is very useful in some cases, and for circles it's also very useful, the compass, so it depends on the personal likes and what you want to do. And also the errors is something important to consider. For example, the equipment you are using may not be perfectly calibrated, and that can be a source of error. Also, the human error. For example, I can see maybe the lines differently than somebody else, and that's a different source of error. Also, temperature. Metal elongates at a higher temperature and contracts at a lower temperature. That's also a source of error. And there's some factors that you have to standardize and put clear in order to reduce your source of error and get the best measurements with the right instrument possible.
You have to choose wisely the tool you are going to use and for which measurement do you want to make. For example, you cannot measure the gauge of a metal sheet with a digital vernier, but you can do it with an analogous micrometer. But for example, it's easier to measure it with a digital micrometer. Why? Because this one, it's an analog, and you can have some errors just by seeing. It's like the operator can make all those mistakes because he can think that it's a right measurement when it isn't. A digital one, it's more exact than a vernier, but a vernier can help you measure some things that the micrometer can let you.
Oscar, do not apply excessive force to the instruments when using them.
Oh, that's right, Pedro, because if you apply excessive force, then you can permanently deform the instrument. Hand it over, Pedro. Please, do not take any material from the laboratory into any other place inside the campus. It's meant for laboratory use only. Thank you.
Keep the instruments used clean at all times.